Welcome. In this short video lecture, we are going to discuss how to construct difference tables. And the next short video lecture will be able to solve some problems related to construction of difference tables. So if you have not subscribed, please press the subscribe button so that you can get further updates on the new classes that will be done on this YouTube channel. So let's go into the work itself. So the first problem, construct a difference table for arguments x equals to 0, 1, 2, 3, 4, 5, 6, 7, and 8 given f of x is this function x power 4 minus x squared minus 3x plus 70. So this is a basic problem. Actually, you should call it an appetizer. So been told to construct a difference table for some values of x when you're given the function. So what you do, you make a table of values of x with their corresponding values of y. So solution. So we make a table of x's and then values of f of x. So 0, 1, 2, 3, 4, 5, 6, 7, and 8. So when you use your calculator, when you replace x for 0 in this function, you get 70. When you put 1, you get 67. When you put 2, you get 76. And then 133. And then we have 298. And then we have 655. And then we have 1312. And then we have 2401. And then we have 4078. So that's usually the first step. Write the table of values of x and then values of f of x. And then once you have done that one, next step is to draw table, the difference table. So this will call it x, and then we have f of x. So x is 0, then you write skipping a line. 1, 2, 3, 4, 5, 6, 7, and then 8. So 0, the answer is 70, 67, and then 76, 133, 298, 655, 1312, 2401, and then 4078. So you skip a line, and then you call this one first difference, second, and then we have third difference, fourth difference, fifth difference, etc. So usually to find these differences, these lines you are skipping between consecutive values are the positions where you'll be writing the differences. So the first difference, you simply take the lower number minus the upper number. So this will be 67 minus 70, you get -3. 76 minus 67, you get 9. 133 minus 76, you get 57. 298 minus 133, you get 165. 655 minus 298, you get 357. Next value will be 657. Next will be 1089. And then next we'll have 1677. Second difference will be now 9 minus 3, you get 12. 57 minus 9, you get 48. 165 minus 57, you get 108. And then next difference will be 192. Next difference will be 300. Next difference will be 432. Next difference is 588. Third difference will be 48 minus 32, you get 36. And then 108 minus 48, you get 60. 192 minus 108, you get 84. Next difference, you get 108. Next difference, you get 132. Next difference, you get 156. And then fourth difference, 60 minus 36, you get 24. 84 minus 60, you get 24. 108 minus 84, you get 24. 132 minus 108, you get 24. 156 minus 130, you get 24. And then this will be 0, this will be 0, this will be 0, this will be 0. And then all these others will be 0, 0. And then can add the sixth difference, you get 0 here, 0 here. And then the seventh difference, 0 minus 0, you get 0. So what tells us that our answer is correct is because all the fourth differences have constant values of 24. We should be expected because we had a polynomial of degree 4. So remember, if you are dealing with drawing a difference table of a polynomial of degree n, then all the nth differences will have the same values. So having all these values as 24 actually is a proof that what we have constructed is a correct difference table for the function given. Now, next question number 2, we can, once we have known how to draw a difference table, we can use it to answer some problems. So number 2, construct a difference table and identify the value with an error from the following list. So we have 65, 66, 67, 77, 101, 145, 215, 317, and 457. So this now, this is an application of difference table. So we have some values given here, and then we are to construct a difference table and identify a possible value with an error. So normally what you do, you draw a difference table with all these values such that, so solution. So, and remember when you're constructing the difference table, what matters are the values of the function. So therefore, this like a function values would be 65, skip a line, 66, and then 67. Next will be 77. Next will be 101. Next will be 145. Next will be 215. And then next will be 317, and then next will be 457. So we call this first difference, second difference, third difference, fourth difference, fifth difference, etc. So we do the same thing, just get the differences, and then maybe we'll be luckier to find a column which has values which are common, and then that will tell us that maybe this is roughly this was the polynomial from which these values obtained from. And from the theorem that if we know that a polynomial is of degree n, the nth differences are uniform, then to help us to correct the error. So what we do next, let's get the differences. So 66 minus 61, 65 we get 1. Then 67 we get 1. This 77 minus this gives us 10. 101 minus 77 gives us 24. It gives us 26. So 101 minus 77. 101 minus 77 gives us 24. And then 145 minus 101. 145 minus 101 gives us 44. Next difference gives us 70. Next difference gives us 102. Next difference gives us 140. Second difference, 140 minus 102 gives us 38. 102 minus 70 gives us 32. 70 minus 44 gives us 26. 44 minus 24 gives us 20. 24 minus 10 gives us 14. And then 24 minus 10 minus 1 gives us 9. 0, 1 minus 1 gives us 0. So when you check this column, so as you draw the differences, please try to observe what is happening. If you find that maybe one column has some values which are repeating themselves, then it can maybe tell you that all the differences in that given column might be having that same value. So for this case, all these values are different. So let's just go to get the next difference. So 38 minus 32, we get 6. 32 minus 26, we get 6. 26 minus 20, you get 6. For 20 minus 14 gives us 6. 14 minus 9 gives us 5. And then 9 minus 0 gives us 9. Now, from what we are getting in the third column, we see 6 is repeating most of the time. 6, 6, 6, 6. So that this one tells us that the third differences, all of them should be 6. And only these two these two values which are not 6 might be they are the ones which are giving the errors in these given values. So therefore, because of many 6 appearing in this column, so that tells us that this value must have been 6, and then this value must have been 6. So therefore, we correct this one. So you can use a different incorrect, make this one 6, make this one 6. And remember, so 38 minus 6 is what gives us 32. 32 minus 6 gives us 26. 26 minus 6 gives us 20. 20 minus 6 gives us 14. So 14 minus 6, then the correct value here should be 14 minus 6, which should be 8. So this 9 was in error. And then, so which means the position of this 9 should be 8. So 8 minus this 6, which should be the correct value in this point, should give us a value here, 2. And then, so these values 0 and 9 were in error, so the correct value should be 2, the correct value should be 8. So then next will be 24 minus 14 is 10. 10 minus 8, because it's the correct value to be here, then we must have 2 here. And then 2 minus 2, this must be 0. So which would mean 1 and 1 were wrong. And then here 10 minus 77 minus 10 is 67. 67 minus this 2 is what should be the value of this point here. So that gives us 65. 65 minus 0, this is 65. So therefore, this error is this value 66 is what was wrongly written. So therefore, you say the value in error is 66 and its correct value must be 65. So that is how we solve that problem. So in the next video lecture, we'll also give further examples on how to apply difference tables. So that's the end. Thank you.